Microbiologically influenced corrosion, or MIC, is basically an electrochemical corrosion phenomenon. This is my short CV to assure you that I know what I'm talking about. Before we talk about MIC, let me remind you that there are two factors to define the importance of something from an engineering point of view: the cost and the risk. The minimum direct cost of MIC is estimated to be about 20% of the total direct cost of corrosion. And on the other hand, the cost of corrosion is about 4 to 5% of the GNP of a country, or the average income of a country's citizens. This means that the direct annual cost of MIC can be expressed in terms of billions of dollars. Although likelihood of MIC could be low, its consequences could be highly critical. Thus, its risk is too high. While accidents such as massive fish kill and development of poisonous fogs and killing of rice crops have been reported as caused by MIC-related bacteria, at least two major cases of oil and gas pipeline failures, one, the BP-owned Trans-Alaskan Prudhoe Bay field in 2006, and another, the explosion of the natural gas pipeline near Carlsbad in New Mexico in 2000, have been reported to be related to MIC. In all of these cases, ecological and economical loss, in addition to sometimes loss of lives, have been experienced. The heart of any MIC problem is the development of biofilms. Although there are many aspects that we still don't know about biofilms and the way they contribute to corrosion, we know for sure that they are certainly a key element in increasing the vulnerability of materials to MIC. Contrary to one of the myths about microbial corrosion, there is not just one type of microorganism or bacteria involved in corrosion. There are many more, and we still don't know many things about both existing and future corrosion-related bacteria. Almost all engineering materials, equipment, and systems are vulnerable to microbial corrosion. This is another hint to emphasize more upon the importance of microbiologically influenced corrosion in engineering practices. Categorically, there are two groups of methodologies that can be employed for the detection of MIC, that is, field and laboratory methods. All of these methodologies have their own pros and cons, and it is always prudent to use more than one of them to double and even triple check the obtained results. Treatment of microbiologically influenced corrosion can be done either by physical or chemical or even biological means. Again, I'd like to remind you that all and each of these treatment methods have their own advantages and disadvantages, and therefore must be applied with necessary care and caution. At the end of this short presentation, I'd like to thank you all and invite you to contact me by my email in case you have questions or want more information. You can find more about MIC in many other resources, including my two books, as you see here. I would like to acknowledge the references I have used for this presentation, and as they are all mentioned in my books with the necessary copyrights. Again, thank you very much, and I do hope you have enjoyed this presentation and also learned about microbial corrosion. Thanks.